sir, for allowing me this particular. So, a very good afternoon to one and all present over here. On the behalf of Mechanical Engineering Department, Parul Institute of Engineering and Technology, Parul University, I would like to take this opportunity to introduce uh, our webinar speaker, Dr. Vinay Vakharia, sir. Sir has completed his doctorate from IIIDDM, Jabalpur in 2013 under the guidance of Dr. Pawan Kumar Kankar, sir. Sir has published several national, international journal and conference papers in his career. Currently, Dr. Vinay Vakharia, sir, is working as an assistant professor in Mechanical Engineering Department, School of Technology, Pandit Deendayal Energy University, Gandhinagar. So I request sir to enlighten us regarding the webinar title, sir. So I welcome you, sir, and I hand over the session to you, sir. Thank you very much, sir.
Yes. Thank you, Mr. Vipul, for giving the nice introduction. And I also thank the organizer of Parul University to give me an opportunity to share my presentations with the bright students and the faculty members of Parul University as well as other universities. So, as you know that today's topic is signal processing and AI applications in mechanical engineering. So, so many people come to know that this particular topics like signal processing and AI, these terminologies are generally used extensively in computer science as well as electronics engineering. So many people are having confusion that these techniques are having only application in that field only. But since scenario is changing, IoT, Internet of Things, Industry 4.0 kind of things are gaining importance day by day. So these particular topics are useful for mechanical engineering applications also. So with this motto and with this aim, I have chosen this particular topic so that people will gain experience that how this particular techniques are specifically useful for several mechanical engineering applications. So let me introduce about myself. I am Dr. Vinay Vakharia, currently Assistant Professor in Department of Mechanical Engineering at School of Technology, PDEU, Gandhinagar. So before beginning, let me little bit talk about my university. So might be people knows that PDU recently has received Center of Excellence from Government of Gujarat. And then we have also topped in the list of NIRF ranking, Gujarat State NIRF ranking. And we are among first in the private university as well as overall ranking. If you see, then we are in the second positions. So this is just about information which I want to share about my university. Then coming to the mechanical engineering department, we are having several programs like BTech in mechanical engineering, BTech in automobile engineering, and then we are having three MTech programs also: MTech thermal engineering, MTech mechanical engineering design, and then MTech manufacturing technology. And currently we are having 35 PhD scholars, in which 29 are part-time and 5 are full-time. And very important thing as far as automobile engineering is concerned, we have started from 2020 and it is supported by international center by Maruti. So these are just introduction about our department. Now let's begin about today's topic. So since I discussed it that the topic of today's webinar is related to signal processing and AI. So coming to the terminologies one by one, let's start with the AI. So what is artificial intelligence? Artificial intelligence is an technique which allows machine to think like human. And there are several things related to the artificial intelligence like machine learning. So machine learning is a subset of artificial intelligence technique. Then people will ask, then what is the difference between machine learning and AI? So machine learning totally depends on the historical data as well as certain kind of programming. But when you talk specifically AI, then it also includes hardware also. So what is hardware related to AI? The hardwares are sensors. So you may be having vibration sensors, you may be having temperature sensors and other kind of sensors. So specifically, we will go one by one, and then we will touch upon certain techniques which are specifically related to the mechanical engineering. So let me begin with my introduction about this machine learning technique. So what is learning? So basically learning is the knowledge acquired through study, experience, or being taught. And frankly speaking, we all people are learner. We are learning each and every activity day by day, hourly. Right now you people are attending this particular webinar, so you are also going to get a certain kind of learning after finishing this kind of techniques. Now coming to the machine learning, what is machine learning? It is an application of artificial intelligence techniques which will learn and improve based on certain kind of experience. What is the idea behind machine learning? So the idea is to build algorithms which can receive data from the users and then use certain kind of statistical analysis to predict the output value. Let me give you a wonderful example. If I'll ask anyone present over here that can you differentiate between the vegetables and fruits, then you can definitely say, yes, we are able to differentiate between vegetables and fruits. And then afterwards, my question will be there that can you identify what are the fruits name and what are the vegetables name? So you can easily identify. So you are seeing right now, this mixture consists of bananas, cherries, carrot, brinjal, tomatoes, and so many things, right? How you will differentiate? My question is that how you will differentiate? Because from the childhood, your parents and society taught you that whenever you see this kind of object, you see this kind of shape, you see this kind of color, then you will recognize it by this particular name. That means we have given certain labels to certain kind of objects. There is no specific logic that why you should call this particular object as a banana or this as a carrot. But we have given them a recognition that whenever you see this kind of object, then you will identify with this particular name, right? So in the same way, machine learning is also working. Means initially we have to teach machine learning that whenever you see this kind of patterns, then you will recognize this one as A category, another one as B category, another one as C category. And then how it will recognize based on certain kind of features. Like again, I'm taking the example of banana. So what are its features? So it is having a specific color, it is having a specific shape, right? So these are the features related to banana. Likewise, there are certain more features related to tomatoes, cherries, and brinjals, right? So to recognize each and everything, you are having certain kind of features, and you have to teach machine learning algorithm that based on these features, you will recognize this particular object. Let me take you another example in the coming slide. So before giving one more example, let's discuss about the types of machine learning techniques. So basically, machine learning techniques are classified into 4 types: supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. Right now I'm just giving a introduction about machine learning technique. Then we will see what are its potential application for mechanical engineering. So basically, supervised learning algorithms are used for regression and classification. We will discuss each and everything in detail in the coming slide. So basically, say for example, you want to predict what will be the taxi fare, or what will be the rate of housing in a particular locality or particular city, then if you want to then you will go for regression analysis. Now, if you want to classify certain kind of object, that means you want to differentiate between men, women, and children, then you will go for classification task. Then, say for example, you want to identify certain group of object. That means you want to segregate, or you want to divide the customer based on, say for example, family background or purchasing capacity and other kind of things, right? So you are going to group them based on a certain kind of historical data. So in that scenario, you are going for clustering techniques. So it comes under unsupervised learning. Then semi-supervised learning. So it is a mixture of clustering and as well as classification. And then reinforcement learning. So you people might be heard about robotics and humanoid robots. And then another example is self-driving car. So all these examples comes under reinforcement learning. So we will touch the relevant techniques in the coming slides. Now let's talk about this supervised learning method. So as I said earlier, that the data contains a response variable in terms of label. That means what you want to predict. That means you want to differentiate between men, women, and children, as well as you want to differentiate between apple, banana, and oranges. That means labels are there. So definitely you need labels. Now, again, it will be classified into two types. You want to differentiate between labels, or you want to predict certain kind of numerical value. Say, for example, might be some people are here from mechanical engineering background. So you want to predict the material removal rate, or you want to predict the surface roughness value. So these are numerical values. So instead of label, there is a numerical value. So whenever you are having this kind of problem definition, then you will go for regression analysis. And to classify and to do certain regression analysis, what are the frequently used algorithms? So popular algorithms for supervised learnings are artificial neural network, support vector machine, and random forest. Now let me give you one more example so that you will come to know exactly how machine learning techniques will work. So this is an example of supervised learning method, right? Now you can see that there are a label which is mentioned over here. So label is cat. And then when you see, it is not cat, it is cats, C-A-T-S, right? That means we are having three categories of cats. Can you differentiate it? Can you differentiate between three categories of cats? Yes, you are able to differentiate three types of cats based on certain kind of features. So just focus on the picture 1, picture 2, picture 3. So these three cats are easily differentiable. On what basis? Based on eye, based on ear, based on certain kind of facial geometry, right? So these are the features through which you differentiate these three cats. So what you are doing, you are passing this information, that means shape of ear, eyes, color, then facial expression. So these are the certain features. You are passing this you are passing this information into your machine learning algorithms, that whenever you see this kind of features, or whenever you are having this kind of features, then you will identify it, right? That means you are training your machine learning algorithm. So training is over. Now let's test that whether my machine learning algorithm is able to recognize it properly or not. So what I'm doing certain kind of tricks. So instead of passing all three pictures of cat, now I'm passing two pictures or two characteristics of cats and then one characteristics of dogs. And at the same time, if my machine learning algorithm is able to differentiate between two categories of cats, as well as it is also able to identify that yes, this dog do not belong to this category, then I can say the recognition capability of my machine learning algorithm is 100%. So I hope this is a very simple example. So you are getting certain kind of knowledge that how machine learning algorithm will work. Now let's come to unsupervised learning. So when the information used to train is neither classified nor labeled, that means you are not having information of output variable in terms of either numerical value or in terms of certain kind of labels, right? So in that situation, you have to use unsupervised learning algorithms. And then what are the frequent used algorithms to do unsupervised learning? Self-organizing map, expected maximization, and then all clustering algorithm. Now let's again visualize that what exactly unsupervised learning means. Now you are seeing another picture of raw data. So again, based on certain kind of learnings, you are easily able to differentiate between the three objects, right? So what are the three objects? So one is, so based on certain kind of geometry, you are able to differentiate. So one is circle, one is triangle, and then another one is certain kind of, say you can name it hexagon, right? So you are passing this information that whenever you see this kind of shape, you see this kind of geometry, then you will identify this particular shape with this particular name. That means again you are training your algorithm, and after training, if your algorithm is able to segregate these three objects clearly, which are shown in the right hand side, then again you can say that my machine learning algorithm, right now in this case unsupervised learning algorithm, gives me 100% accuracy. So I hope with this example, right now at this stage, you are able to differentiate between supervised and unsupervised learning algorithm. Let's talk about a very important semi-supervised learning algorithms. So there are certain cases in practical life that you, at certain times, you are having certain information about a particular person. That means you are able to know that this information belongs to this particular person, and at the same time you are having certain information but you don't know that this information is related to which particular person. So in that situation, what you will do? So for that situation, there is another type of machine learning algorithm which is known as semi-supervised learning. So it contains a small amount of labeled data and a large amount of unlabeled data. Let me give you one more example that this kind of semi-supervised learning algorithm will be used by certain agencies for search of new solar system. So many people will wonder that how this particular algorithm will be used for search of new solar system. So for searching new solar system, what specific objectives we want to know? That yes, whether water present over there or not, what is the concentration of oxygen, what is the presence of nitrogen, right? So we are looking towards this certain kind of characteristics, right? So we are teaching our machine learning algorithms that, see, whenever you find this much amount of water, or you identify that water is present into that particular solar system or maybe in planet, then what is the concentration of oxygen, what is the concentration of nitrogen, right? You are asking this information to machine learning algorithm, because this gives us an indication, yes, if this characteristics are present in solar system, then might be there is a possibility, yes, that life exists into that particular planet or solar system, right? So that kind of information will be used for the existence of life on our solar system as well as other solar system. Let me give you one more example. Related to this thing. So now again you can see that there are few labeled data. So you can see that data again are having different shape as well as different colors. So we are teaching our machine learning algorithm that whenever you see this kind of data, you see this kind of objects, you see this kind of colors, then you will segregate it, right? And then now I'm passing many unlabeled data which are having a different color as well as different shape. And then afterwards, again, I have to retrain my classifier. And again, if my algorithm is giving me more than 95% accuracy to identify as well as segregate different objects, then I can say, yes, my algorithm is better for identification of this kind of task. So in a nutshell, you can visually see the difference between supervised, unsupervised, as well as semi-supervised learning methods. So if you see the figure of supervised learning algorithm, then if your algorithm is able to clearly separate the two objects, like what are the objects over here, which are presented in blue color as well as which are presented in the green color. If your algorithm, any of your algorithm is able to segregate these objects clearly, then yes, your algorithm is perfect for that particular task. Let's come to unsupervised learning. What is unsupervised learning? That means we are segregating different objects, and then we are making certain kind of clusters. So you can see that two clusters are formed, and again these clusters are easily separable. So again, in that situation, your algorithm is perfect. And then semi-supervised learning, it is able to differentiate between green color, blue color, as well as it is also able to differentiate between that circles. And then that particular data is not coinciding with each other. So you can see the vertical margin in semi-supervised learning, vertical margin, which is shown by black color. And then again, another margin, which is inclined. So you can see the data are easily separable, right? So this is the visualization for these three learning methodologies. And then these are the architecture of machine learning algorithm. So as I said, that these machine learning algorithms totally rely on the historical data. That means you need certain kind of information about the particular person or particular objects. So based on certain kind of characteristics, and in machine learning algorithm, that characteristics are known as features, right? So without features, without raw data, your machine learning algorithm will not work. And the correct terminology is that yes, we need historical data. Then that particular data will be divided into training and testing. So again, certain people are having confusion. What do you mean by training? What do you mean by testing? So let me give you a very simple example. Say, for example, I am conducting lecture in my university and I am taking 14 lectures. So I am training my students to a particular subject with that 40 lectures. And if I ask at the end of my lecture that did you understand each and everything, then certainly what will be the answer? Yes, sir, we learned each and everything perfectly, right? But we don't rely on that kind of comment. So what we generally do, we are generally going for mid-semester assessment, internal assessment, as well as end semester assessment. That means we are dividing that particular data into training and testing. Means we are conducting certain kind of test to assess the learning capability of students. So the thumb rule to divide any kind of data set is 70-30. This is the thumb rule which most of the researchers and working professionals worldwide they are using. But again, it depends on the availability of data sets. So when you are looking towards certain applications related to electronics, software, and other kind of things, banking, finance, credit card, so you are having ample data. Data is huge. right? So you can easily divide it into the 70-30, 60-40, 75-25, whatever. It totally depends on the knowledge of the engineer. Now, the real challenge comes to the mechanical engineer. If I am a mechanical engineer, if I am a chemical engineer, if I am a civil engineer, right, I am also having a certain limitations related to the experimental data set. I do not have experimental data set in terms of thousands, in terms of 5,000. In certain cases, in certain application, I am always limited to maximum 70, 80 data set. Then again, there will be a challenge that how much I will partition for training, how much I will partition for testing. So this is a real challenge for the core engineer. So how we will use it, I will define it in the next slide. So this is just a brief introduction about the architecture of machine learning algorithm. Now let's come to towards the today's topic related to the ML application in mechanical engineering. So whatever we have discussed so far, it is a general overview how machine learning algorithm will work and what are the essential things which will be needed to get certain kind of prediction based on the information which user provided. Now let's talk about the mechanical engineering applications of machine learning. So there are certain kind of challenges as far as mechanical engineering are concerned. So you can see there are two applications. So on the left hand side, you are seeing the certain classes of the bearings, right? So what does it mean? That means I am having a healthy bearing, which is defectless. Then I am having another bearing, which is having a fault on the balls on the bearing. Then another bearing, which is having a fault on inner race. And then last bearing, which is having a fault on outer race, right? Now, I want to know that whether my machine learning algorithm is able to differentiate between all these 4 fault categories of bearings or not. So this is the challenges. Another challenge. So when I want to gather this particular data related to ball bearing, so generally we use the vibration signal. So I am having challenges that how I will collect the data. So this is a very, very important challenges for a mechanical engineer. So to overcome these challenges, we have to use certain kind of signal processing techniques. Another challenge, I want to differentiate between the certain specimen manufactured through various machining operations. Like you can see this particular specimen is manufactured through shaping, then another one through sandblasting, then milling, and then EDM, right? I want to differentiate between these 4 specimen of different manufacturing operations. How I will get this particular data, right? So again, to solve these particular challenges, I have to go for image processing techniques, right? So these are the challenges related to the mechanical engineering. Data kahan se laoge? Machine learning algorithm to baad mein lagaoge. Where you will get the data. Now let's talk about this thing. How you will solve this particular challenges. So as I said earlier, that we need certain kind of instruments to get that particular data. So these are the certain equipments which are available in our lab, and my PhD students as well as MTech students as well as BTech students using this particular experimental facilities. So basically it is a machinery fault simulator. So you can see that bearing is mounted over here. What I'm doing with this particular bearing, that I'm continuously changing this bearing with respect to the 4 cases. What are those 4 cases? Healthy bearing, fault in outer race, fault in inner race, and fault in bolt, right? And then these particular signals I'm capturing with the help of this particular accelerometer. So you can see in the down slide that yes, accelerometer are mounted, and then this accelerometer are associated with certain kind of signal conditioner and other kind of techniques, and then that information will be passed into certain kind of softwares, and then you can see certain kind of visualization of recorded signal, right? So with the help of this instrumentation technique, you can gather this kind of data. Another challenge is how you will capture the images of a specimen. So again, we are having this particular instrumental facilities into our university. This is known as CCD camera. That means charge coupled device camera. It is a very high resolution camera. So we can generally put the manufactured specimen over here, and then images will be passed into certain kind of softwares for certain kind of filtering techniques, and then we will gather the data, right? So this kind of challenges will be overcome by this kind of instrumental facilities available into the labs. Now let's come to the signal processing techniques. What are signal processing techniques which are associated with this kind of vibration signal? So basically signals are divided into three types: time, frequency, and time frequency domain. So you can see that this time domain signal are generally rich in content. I'm just observing the patterns, right? I cannot get much more information what exactly my signal carries. I just get the information that yes, these are the amplitude of the vibration with respect to particular second. Then coming to the frequency domain signal, I will just convert this time domain signal into frequency domain signal, and then I will come to know what frequency this particular signal carries. And then yes, I want to know exactly at what time this particular frequency exists into my system, then I have to go for time frequency domain analysis. Again, there are certain merits as well as demerits of all these three techniques. So coming to the time domain signal, you can easily see that yes, this left hand side picture is continuous signal. That means it is uniform in nature. But if you see towards another signal, it is not uniform in nature. It is having certain different kind of spikes, right? So I'm just getting a raw information related to the time domain. And then at the same time, I'm also having challenges related to the time domain, that it just carries the information of the signal. It will not tell whether fault exists into my system or not. So to overcome this kind of challenges, I have to use frequency domain analysis. So generally in frequency domain, there is a technique which is known as fast Fourier transform, FFT. So you are converting your time waveform into the FFT. What is FFT? It is generally a plot between frequency versus amplitude, and it is giving a certain kind of peaks, right? So by knowing certain kind of peaks, you will come to know that whether fault exists into my system or not. This is the advantage of frequency domain. Now, again, there is a challenge that I want to know at what particular instant this frequency appears into my system. Then I have to go for time frequency domain analysis. So there are so many techniques like STFT, Wigner-Villay distribution, and wavelet transform, which are popular techniques for visualizing this kind of challenges. So as you can see, this is a pictorial representation of wavelet into the 3 dimension. So basically you can see the translation, scale, and amplitude. So basically translation resembles to the time information, scale resembles to the frequency. So scale is a reciprocal of frequency, and then you can see the amplitude. So generally, there are certain characteristics when you are plotting wavelet 3D. So generally, high scale correspond to low frequency, and low scale correspond to high frequency. And you can see that I will get, once I plot this wavelet 3D, I can easily come to know at what instant of time my frequency appears into the system and what is its amplitude of vibration, right? So I am going to get this information with this combined time frequency domain signal analysis, right? So these are a little bit introduction about the introduction about the signal processing techniques. Now let's see how these techniques will be useful for the mechanical engineering applications. So basically, this is the case study related to the wavelet selection using minimum multi-scale permutation entropy criteria. So I have just given an introduction or information about the wavelet. But when you search on the Google, there are more than 150 wavelets available. So there is again question, which wavelet you are going to use for your particular application. So we have proposed this wavelet selection criteria during my PhD work at IIIT IITM Jabalpur. So as I said, the objective is to propose this permutation entropy to select the best wavelet. And at the same time, it will be able to differentiate the different kind of bearing faults as well as their severity level. So to select the best wavelet, we have used these four mother wavelet, which are like Simulate, Coiflet, Shannon, and Morlet. And as I said earlier, the wavelet which is giving me the least permutation entropy, which will be further sent to the machine learning algorithm for identification of faults. So this is the flow chart of this particular methodology. So what we are doing, we have taken the data of Case Western Reserve University, which is publicly available. Anyone can use this data set for their research work. So we have taken the data set from that particular bearing test rig, and there are four classes like healthy bearing, fault in outer race, fault in inner race, fault in ball, as well as another one, right? And then what we are doing, we are going to apply the wavelet technique into that, and then we are calculating certain kind of coefficient, and with that coefficient we have calculated certain statistical parameters. Now what do you mean by statistical parameters? That means we calculated for a particular signal what is its mean value, what is its standard deviation, what is its kurtosis value, what is its skewness value, what is its RMS value. So based on all 40 cases, we have calculated all these features, and then this particular feature vector which is formed is fed into the machine learning algorithms. Right. So this is one of the potential applications. Now there is also one more challenges which certain reviewer asked when we presented this paper for the publication. Then there is a comment from that particular reviewer that okay, your machine learning algorithm is giving you the best accuracy, fine, but the criteria which is proposed by you, that means permutation entropy, is able to differentiate between various fault categories or not. Can you give us certain kind of visualizations related to that, or certain kind of findings with that? So again, it's a challenge for us at that time. So again, we have mitigated that challenges also. So you can see that this permutation entropy which is marked over here, so it is able to differentiate between rotational speeds. See, you can just focus towards this particular variation of speed. There is a very least variation in the speed, 1730, 1750, 1772, 1797. That means range of speed is also limited. And then there are three categories of fault: ORD, BD, IRD. Right. So you can, when you look towards this particular figure A, then this permutation entropy is easily able to differentiate between these three categories of fault, as well as, yes, it is also able to differentiate the permutation entropy value with this least variation in the speed. Again, why this Case Western Reserve University data is important? You can see the magnitude of fault, 0.17 mm hole, 0.17 mm hole, then 0.35 mm hole, then 0.53 mm hole. You can see that hole or defect size is very, very less, but our algorithm, our criteria is able to differentiate between these three fault categories as well as these three fault severity level. As I said earlier, that there are only 40 cases available with that Case Western Reserve University data. So again, as I said earlier, that mechanical engineer, civil engineer, chemical engineer, core engineering people are always facing problems related to the experimental data because cost and time are associated with it. But yes, if you are having proper knowledge, if you are having proper algorithm development capabilities, then you can also do that kind of analysis. So you can see out of 40 cases, our algorithm is easily able to identify 39 cases, and only one cases is misidentified. So we have used three algorithms: artificial neural network, support vector machine, and radial basis function. So in that situation, our maximum accuracy is 97.5%. So what does it mean? That means out of 40 cases or categories of bearing, our algorithm is able to identify all the 4 cases with 97.5% accuracy. So this is a first case study. All these things are related to the signals, vibration signal, which are one dimension. Now, what happens when you want to go for image processing techniques? So this is again a case study related to my MTech student, Mr. Jamin Panchal. So we have proposed another technique which is related to the image processing techniques, and then generative adversarial networks. So this is a game changer. GAN, generative adversarial network. This is the game changer technique in machine learning. So you will see in coming years, this technique will be the mostly used by AI and ML engineers. Right now, it is in development stage, and people will come to know its benefit in the coming years. So before going to this GAN, people are also having certain kind of questions that is there is any difference between machine learning and deep learning? Yes, there is a difference. As I said earlier, so you are having certain kind of inputs. You are going to extract certain kind of features from that input, and then you are passing this feature vector to your classification algorithm, and then it will be able to identify or differentiate between car and no car, right? So this is generally a machine learning technique. Now, what is deep learning technique? So instead of passing this information, instead of calculating feature and other kind of things, you are just passing this information into your deep learning algorithm. It will automatically calculate the features as well as it will be going for the classification, and then again it will give you an output, whether it is a car or not car, right? Again, one more very important thing, machine learning techniques, you can use it for 1D signal or 2D signal. That means you can use it for single dimension as well as pictorial representation. But in maximum cases, in case of deep learning, maximum cases you need to have certain kind of pictorial representation. Now, what are pictorial representation? You have to convert your coefficients into scalograms or spectrograms. Let's see how it will be useful. So the objective into this case study that whenever we are having challenges related to the small data set, as I mentioned earlier, then in that situation, can I enhance my data set? Can I enhance my data set? Yes. So in the coming years, the challenges will also be made by this popular generative adversarial network. So just for visualization, I'm giving you an example. there is a horse and there is a zebra. There is a horse, there is a zebra, and based on certain kind of features, I'm teaching my machine learning algorithm that yes, based on certain kind of characteristics, please identify this as a zebra or please identify this as a horse. So I'm training my machine learning algorithm that yes, based on these characteristics, you will be able to differentiate between them, right? Now, second task, very interesting task. Computer science people have used it, and now they are extensively going to use it in the coming years. Now my second task is to convert that horse into zebra and then zebra into horse. Right, this is again researcher, this is a very, very important problem definition which researchers are facing. Are you able to differentiate this zebra into horse or horse into zebra, right? So to address this issue, you have to use GAN, right? So I have given you the example in what situation this particular GAN will be useful. So this is a flow chart for this case study. So again, we have used this Case Western Reserve University data as well as MFS data for our study. So we have measured the vibration signal, and then that vibration signal is converted into this spectrogram. So this is the real data. And then, as I said, we are only having 40 data, right? So in that situation, deep learning techniques will not be useful. To employ deep learning techniques, you need huge amount of data sets, right? To overcome that limitation, we have to go for the artificial data set. So with this real data set, we have generated the artificial data set, which are actually the close part, or I can say the child of this real data. So instead of 40 data set, now I am having 160 data set. And then these images will be passed to certain deep learning techniques for feature extraction. So convolution neural network will be used or have used for feature extraction. Feature vector is created and then it will be passed to the certain machine learning algorithms for fault identification. So we have used a very popular technique like support vector machine and random forest for fault detection. So now you can see that there are 4 figures. So this figure A belongs to Case Western Reserve University data at 1797 RPM. So it is an original data. And then when you see towards this figure B, then again it is of Case Western Reserve University data at same speed 1797 RPM with outer rust fault condition, but it is artificially created. Looking towards this figure C, again, it is a MFS data, machinery fault simulator data, which belongs to outer rest fault at 1800 RPM. And then this figure D is belonging to artificially generated data at 1800 RPM. So there is a close resemblance between these pictures. So right now I'm not discussing it in detail. We have done all this kind of analysis. And then there are again challenges that yes, with your algorithm is able to differentiate between 4 classes or not. So this is first challenges. And now I want to visualize that how many how many fault cases are able to identify correctly or not. So when you look towards this particular figure SVM, so for healthy bearing, all 160 cases are identified correctly. But when you look towards this ball fault, B1 resembles to ball fault. So out of 160 cases, 156 cases are correctly identified and 4 cases are incorrectly identified. And when you look towards inner rest defect, all 160 cases are correctly identified, and outer rest, only 1 cases is misidentified and 159 cases are correctly identified. When we go for the artificially generated data, then you can see all the 160 cases are correctly identified. So this is the utility of this particular GAN technique. Again, we have applied same technique for MFS data, right? So again, 160, 159, 160, 159. And then when you look towards this artificially generated data, then again 160, 160, 160, right? That means my algorithm is able to identify, our proposed methodology is able to identify all the fault cases for the experimental data as well as for the synthetic data. So this is the beauty of this particular GAN technique. So this confusion matrix, basically this technique, this table is known as confusion matrix. So it gives us a visualization that out of all fault cases, how many cases are correctly identified, that to belonging to certain categories. And this is our accuracy. So you can see that with CWRU data, Case Western Reserve University data, actual data, we are able to identify all fault cases with 99% accuracy. And with Case Western Reserve University data, which is artificially generated, we are able to identify all the fault cases with 100% accuracy. Coming to our own experimental data, MFS, we are able to identify fault cases with 92.81% accuracy. And coming to MFS DCGAN, that means artificially generated, maximum accuracy is 99.06% accuracy. So you can see that how much robust our methodology as well as our algorithms are. So we have implemented this algorithms as well as these techniques into the Python. So this is the work of my MTech student who has just recently passed out, and right now he's working in Infosys. So he's having knowledge of all this kind of techniques. So coming to end, what will be the future technology as far as mechanical engineering is concerned? Again, it is related to the computer science and other biomedical applications also. But since today's topic is totally focused on mechanical engineering, so there is a challenge that what will be the applications related to the synthetic data. So this particular terminology, synthetic data, you will be going to hear soon in the next few years only, right? Synthetic data will be going to get popularity. Again, synthetic data will be of one dimension in nature and two dimension in nature, right? And this synthetic data has been used by so many industries, so many credit companies also. They are using this data for able to differentiate between the potential customers for providing certain kind of loans as well as credit card. Then data augmentation techniques. How I will apply certain kind of geometrical transformation so that I can get maximum information from my data, which I captured through the experimentation. Then cyber physical system. So basically this cyber physical system is nothing but IoT or Industry 4.0. So basically it is related to the sensors, and at the same time it is related to certain kind of monitoring techniques. Means I'm working over here, and say for example certain kind of faults exist into my system, or it is noticed into my system, so that information will be immediately transferred to my colleague which is sitting in the Bangalore, and that particular person will able to stop or rectify that particular situation from the remotely operated locations. So this is a cyber physical system. Then advanced robotics or humanoid robots. So this is the best example, and might be you have heard that certain kind of organizations utilize humanoid robots instead of human for certain kind of tasks. So a few days back I have read in the newspaper that in Japan or certain kind of European nations, they are using robots in the restaurants for delivering certain kind of dishes, right? So this is the future which we cannot avoid, right? And at the same time, this humanoid robots will be also using for firefighting. And as I said, Industry 4.0 and Internet of Things, right? So the purpose of this particular presentation is that you cannot avoid this AI and machine learning techniques. And if you think that, yes, I'm a mechanical engineer, I'm a civil engineer, I'm a biomedical engineer, or I'm a chemical engineer, these techniques are not useful for me. No, in that situation, you are totally wrong. And believe me, certain mechanical industries are entered into this kind of things. So with Seat Tiles, which is located in Halol, we are developing this kind of techniques, which will be the future and game changer in that situation. Again, in certain organization, I don't want to name right now, we are working closely for the automation as well as machine learning techniques, so that their production capacity will be increased, and they can do certain kind of business intelligence decisions, right? So with this thing, I'm closing my presentation for today. Thank you very much for patiently listening. And now you can ask any kind of questions if you are having. Thank you very much.
So thank you very much, sir, for your knowledge, for your experience sharing with us. I would like to take this opportunity as a vote of thanks. Thank you very much, sir, for sharing your experience and knowledge regarding the field. On the behalf of Mechanical Engineering Department, Parul Institute of Engineering and Technology, Parul University, be grateful to you, sir. We get knowledgeable things from the session, and we hope that we are able to implement the things in our research area, in our research field, and definitely we will get some insight from the particular session. So I would like to say thank you very much, sir. And the question, if I'm going to receive from the listener, I will definitely pass on to you for your knowledge,
Yes.
for your concern.
Yes, thank you very much for giving me an opportunity to share this wonderful technology with the students, faculties, and the other people present over here. Yes, I'm ready to answer a few questions. If anyone is having any query or any questions, you can ask.
Right now, sir, the particular person who are available in this link are the technical person and the speaker and the
Yes.
moderator only. But if
Yes.
I'm getting the question from the Facebook or from the email also, I will definitely pass on to you, and later on I may definitely transfer the answer to them. So
Yes.
thank you very much, sir, for your time, precious time for us. Thank you very much.
Thank you. Thank you. Thank you very much.
Okay, sir.
65 participants थे सर.
बढ़िया, not bad. इस मंगा दो, ये कौन सा वो? तो वो भी मंगवा लेता हूँ अगर देने को.
वो उन्होंने कर लिया.
ईमेल आईडी भी मंगवाता हूँ. Data is everything.
हाँ वो तो है ही सर.
ईमेल चाहिए, फोन नंबर चाहिए, जितना मिलता है सब चाहिए.
अब देखो ये हम लोगों के पीछे पड़े थे. अब
हाँ वो वाला.
हाँ वेबिनार अब
आपने तो कर दिया ना. चलो था.